Well, welcome. I'm going to get started. This talk is titled Greater Than the Sum of the Parts, and it's about a project where we integrated Pyramid and Plone and React and a bunch of other things. My name is David Glick, and I've been a part of the Plone community for 9 years now. This is the shirt from the 2006 conference in Seattle, which was actually a year before I got involved, but that's where I live, and I picked up a t-shirt from my former employers who had hosted that conference. This is my first conference in a few years, so it's good to be back and see you all. Thanks. I'm currently doing work with Jazzcarta and with a company called Oddbird that does non-Plone related web things. This is a talk about the project we did for the Washington Trails Association. I hope my voice holds out. I have a bit of a cold. We built them a volunteer management system. So WTA is a large nonprofit in Washington State, and they do a bunch of things. They maintain trails. They advocate for the state to protect them. They promote hiking. They're celebrating their 50th anniversary this year. And the project we did was a partnership between Jazzcarta and Percolator Consulting, which was their Salesforce consultant. So this is a talk about building a complex system out of smaller parts. And I gave in the title, greater than the sum of the parts, and that makes it sound like, oh yeah, this is what you want to do. You know, you take a bunch of run-of-the-mill parts and you put them together and you get something really awesome. But it's not quite that simple. There are trade-offs. If you take something simple like that toy car on the left. It's got some advantages. It's unified, it's straightforward, it's easy to reason about. On the other hand, there's only one way to do it. It's not very flexible in terms of how you use it. A complex system is more like this Lego car on the right. There's lots of parts. You can put them together however you want. Some of them are going to work better than others. The advantages are that it's flexible and you're not locked into one way of doing it. But there's more potential for both, great success or great failure, and it could be a bit of a puzzle to put it together. Part of the thesis of the talk is also that the tools you use matter. The choices we make about tools have an impact on how successful we are and on how much fun we have using them. So while I said greater than the sum of the parts, the point is really that if you're going to build something complex, it's going to be painful. But if you pick the right things to use to do it, it can help make up for some of that. That also means that this is a talk for developers. I'm going to talk about the architecture we used, but then I'm going to dive in. I'm actually going to show a little bit about how Pyramid and React in particular, about how they work and why they were a good fit for the project. So this is the WTA website. WTA.org. It's a Plone website. This was there before we started the project. It was built by Groundwire a while ago. And it's a very popular resource for hikers in Washington State. They come here to search for hikes. They can keep track of where they've gone hiking, submit trip reports so that other people can find out what the trail conditions are, that sort of thing. But this is just a part of a broader set of tools. And by the way, Charlie, can you raise your hand? Charlie is from WTA and is our main contact there. Glad to have you here. The website is just part of the technology. Before the project, there was the website. There was Salesforce, which is used for keeping track of donors, keeping track of who are members in the organization, keeping track of who's a volunteer. And then there was also this thing in the bottom right, which was the volunteer management system. This was a completely separate website, obviously not styled very well. Was sort of a decade-old pile of Perl scripts. So that was what the goal of the project was to replace that with something nice and modern. So let me just show you a little bit about what we ended up with, what we created, and then I'll talk about how we built it. So you can find a work party. We've got this nice faceted search. You can search by region or other characteristics, see what's coming up. These are trail work parties, so chances to go out and be a volunteer fixing up the trails in Washington State. And we can show the results as a list or a map or a calendar. There's a registration form. So once you pick one of these, you fill out the form. You can sign up yourself. You can sign up friends or family. You can put in, whether you're looking to carpool to the trailhead. And you can also sign up to get an account on the WTA website if you don't have one already. There are a bunch of tools for crew leaders who are organizing, so they can see a roster of who has registered for a particular work party, see who's on it, how much skills and experience they have. There's also a message board so that they can communicate with the people on the crew. And there's also some other forms and things that they can access. There's also reports available to WTA staff, to the crew leaders, and also to representatives from the various organizations that manage the public lands. And so you can come here and see how much work has been done on a particular set of trails in a particular set of time. So we were looking at the plans for all this and asking ourselves, what is the right technology to use? Building the entire thing in Salesforce was an option. Salesforce is a platform that supports a lot of things, and that was where WTA staff wanted to enter data and manage it. So in some sense, it made sense to build the user-facing front end there. But on the other hand, as a completely hosted environment, Salesforce can be a little bit awkward for doing rapid development. You have to run everything, they enforce test coverage, which is good, but you have to write your code in Apex, and the tools for doing visual things it limits your options. And there's also restrictions on the licensing, which meant that if you're building something that's going to be used by a large number of people, that can start to be a factor. Plone was also something that we considered, and it could have been a natural choice because that's where all the user accounts were. People are already logging into the site when they're searching for hikes and that sort of thing. But in this case, we figured that the feature set we were building didn't necessarily overlap a lot with Plone's content management features, and there wasn't necessarily a lot of benefit to having it be one unified thing in the CMS. So this is the architecture we ended up with. You can see the CMS on the right, that's just Plone, normal. On the left is VMS, the Volunteer Management System. So what we did was Salesforce is down there at the bottom. That's where all the data is stored. That's where WTA staff are entering things in. We have a pyramid app, which sits in the middle, and that takes care of a couple of key things. It pulls data out of Salesforce once a minute and indexes it in an Elasticsearch. And we use that to do the faceted search for the work parties without hitting Salesforce, because Salesforce has pretty limited restrictions on how often you can call their API unless you pay extra money and that sort of thing. And then it also takes care of just access control. So Pyramid communicates with Salesforce via a REST API. It's a privileged Salesforce user that can do a lot of things, so we can't just use that from the client side. So we have a bunch of API endpoints that we built in Pyramid that will make sure that a particular user can only do what they're supposed to, and then it sort of relays things like a command to register over to Salesforce. Up in the browser on the VMS side, we used React.js to build a nice polished UI that is interactive and a nice thing to use. So that is what we built. Let me tell you how we built it. Specifically, let me talk about Pyramid for a little while and why we like it. This is sort of going to be a smorgasbord of different things about Pyramid. So like I said, a lot of the app is just endpoints that serve JSON. I won't call it a REST API because it's more of remote procedure call. We sort of needed more control over how much interaction is going to happen with Salesforce and that sort of thing, as opposed to just exposing a broad API that does a lot of things. But in any case, Pyramid's view configuration system is very nice. If you look at this code for registering a view, you'll see things that you recognize from Zope. We're registering it for a particular context in this decorator here. We're giving it a name, but you'll also see some other things. Both of these are views with the same name, register. One of them, the one at the top, is the one that shows the registration form. The one at the bottom, you'll see it has request method post. That means it's only going to be used if it's a post request. So this is the one that handles the form being submitted. And that's called a view predicate. And Pyramid's very flexible about being able to register different conditions under which different views will be used. I also like these view decorators because it keeps the view configuration right next to the code that's going to be run. You don't have to keep flipping back to a ZCML file or whatever. Unlike some micro frameworks, in Pyramid, when you put that decorator on a view, it doesn't magically register it right away. It just, stores some metadata. The actual registration happens when you start Pyramid up, and some code like this runs, and we create a configurator, and we tell the configurator, go and scan that views module and register any views that are in there. That's a good thing. It means there are no globals, no global state in Pyramid for the most part. And that's good. It makes it possible to test just part of the system. You can scan in your test, just scan the parts that you want. It also, this is something that only is relevant sometimes, but if you want to run two different Pyramid apps in the same process, it makes it a little bit easier to do that. Avoiding globals is not the only thing that makes Pyramid views testable. If you look at this view, you see it just returns a dictionary. And that is generally true of Pyramid views. That means that in your test, you just run a view and you get back a dictionary, and it's pretty easy to check and make sure it has the right thing in it. As opposed to the sort of views we're used to in Plone, where it actually returns a rendered response. And then you would have to parse that and if you wanted to make assertions about it. There's a renderer that's mentioned in the view config. The dict that we return from the view is going to get past the renderer. It could be JSON renderer, it could be a template, it could be something else, and that will take care of actually creating the response from what the view returns. A couple other things that Pyramid ticks the marks on, runs on Python 3, has really good documentation. And then there's this set of things that I like Pyramid because it's good. It's a framework that's good at creating frameworks. Why was that important for this project? Well, like I said, we're using Salesforce as the data store. So we aren't using something like a SQL database or the ZODB that there are established patterns for how you do this in Pyramid. So we sort of needed to build some infrastructure ourselves. So a few ways that Pyramid made that pretty nice for us. Request properties. So, we're going to be using the Salesforce client all over the place in different views. So it wouldn't be nice if we can just say request.salesforce and, get it, as opposed to needing to import something from somewhere. Pyramid makes this really easy. So in your configuration, we have this, we create our Salesforce client, we have a method that returns it, and then we just say add request method and call it Salesforce. And that will take care of making sure that every time we get request.salesforce, it's a lazy sort of thing. So the first time you get it, it'll do whatever. It'll call the method and get it, but then it'll cache it. So if you use it again in the same request, you'll get the same object. So that's handy. Pyramid also has tweens. A tween is sort of like middleware that lives within your application. So it's something that's going to be processing every request as it comes in, and it can do something with it if it wants to. So we use this for doing single sign-on. So when you try to log in to VMS, if you're not logged in already, it'll redirect you over to the Plone site, to the login form. And then you go through the normal Plone login process. Plone will see if you came from the VMS app, and if so, it will redirect you back, and it'll put a little token in a JSON web token in the query string. And we have this tween, which gets called for every request, and it just says if the SSO token is in the request's get variables, then we do what we need to handle set up a session here in Pyramid. Otherwise, we just return handler, which is the next thing in the chain of tweens that lead down to the actual application, and it'll continue processing like normal. Another frameworky thing we had to do was because we were serving all these JSON views, we wanted to make sure that if we hit an error, we would actually return JSON if the browser had requested that. So with Pyramid, like with Zope, you can register exception views. So if the application hits an exception, it'll look to see, is there a view registered for this type of exception? So we registered just a generic one for any exception, but we put that predicate on there for whether the browser is accepting application JSON. So this is going to be used in that case only. If you're loading HTML page, we hit an exception, then we render the HTML. But if you're getting JSON through AJAX, then it will hit this. It'll format it as a dictionary and return that, render it as JSON. Could somebody go get me a glass of water or something? Thanks, Kim, or Sally. Pyramid has, I've talked about a little bit, the configuration system. That makes it possible to have packages that provide some pre-existing functionality that you can include in your application. So these are some ones that we used. Pyramid Chameleon is the Chameleon template system, which we used for some of the templates, the places where we weren't using React. Pyramid Layout was created by Chris Rossi, who's been in the Plone community some, and it sort of provides like a main template sort of thing, so you can use the same layout for your template, but just insert your actual content into a portion of it. Pyramid Cache Bust is helpful for including CSS and making sure that whenever the file changes on disk, we'll serve it with a unique identifier so that it breaks out of any caching that you've got. Thanks, Sally. And Pyramid Mailer is useful for sending mail out of your Pyramid site and making sure that it is tied in with the transaction system, only goes out if the transaction succeeds, that sort of thing. There was this really nice thing that happened because we used Pyramid for this. And this is really less of a property of Pyramid in general and more something that was true of the particular application we were building. But because we weren't using a database really at all, we were just using this as an intermediary to call Salesforce. The memory footprint was pretty low. That meant it was pretty easy to run a whole bunch of threads in our what you can call it, WSGI server. And this was important because when WTA opens registration for work parties, it happens on a particular day, and there are people who are waiting to register for the very popular work party volunteer vacations, where they get to go out and go camping and volunteer for a week. So they get a lot of requests within about 10 minutes, right when that opens up. So this made it a lot easier to deal with that. If we had built this in Plone, the first half dozen requests would have come in, and then it would be sitting there waiting for a couple seconds to get a response from Salesforce, and meanwhile nobody else can get it. They just have to be queued up. And this way we could have a bunch of threads going, handling those. There were a few things that I don't think are perfect about Pyramid. Overall, I've really enjoyed working with it. Some of those things are it doesn't automatically provide CSRF protection like we have in Zope now. So you have to sort of remember to check CSRF on each view. I think Donald Stuff has done some work on this as part of the warehouse stuff he's working on for PyPI. I can't remember if it's been merged yet, but it may be working better soon, or at least have better facility for doing that if you want to. The exception views that I mentioned, they are themselves handled by a tween. that means that if you have your own tween that sits outside of that and it hits an exception, it's not going to go through the normal machinery, and you're going to get like an ugly, whatever your WSGI server exception is. So just something to watch out for when you're ordering your tweens. And then just as a more general comment on Pyramid, it is a some assembly required sort of system. You're going to have to make some choices about how you want to use it and what pieces you want to put together. That's a strength if you want to use particular pieces, and it's a weakness if you just want something that works. One thing that in particular I found was annoying to have to think about was setting up logging and making sure that logs were going to a reasonable place. I'm going to talk about testing Pyramid a little bit because I really enjoyed the flexibility that it gave us, and we did a number of different kinds of testing. We used the pi.test framework, which people seem to either love or hate. I like it. It's a bit magical, but it keeps your tests clean and concise. Pi.test makes it really easy to define fixtures. A fixture is just a function that returns something. But then you can see the second one takes the parameter work party, and pi.test is automatically going to say, oh, there's a work party fixture. I'm going to call that and inject it in there as a basis for your test work party test. So it sort of provides similar functionality to what test layers do when we're testing in Zope and Plone, but it's a little bit more granular. You can include multiple different fixtures for a particular test. The other magic thing it does is around assertions. So normally when you do an assert in Python and it fails, it just says assertion error. It doesn't tell you anything useful. And pi.test makes sure that it'll actually say, oh, that thing was not equal to that thing, so you can debug your test. Because we were doing all this talking to Salesforce, we wanted to be able to test things without actually talking to a live Salesforce instance. So we did a lot of creating fixtures using Factoryboy. And Factoryboy lets you define a factory for your fixture, and then any time we need to get a work party for a test, we just call this thing, and it's got a sequence there that will increment something every time it gives us one. It's got a thing that generates a random date and time between two endpoints, and it's got a subfactory that refers to some other factory. So it just is a useful toolkit for building things for testing. We did some testing of functionality at the HTTP level because this is sort of an API server. Web test is the thing to use for this. Gives you a wrapper around the WSGI app that just is sort of like HTTP, so you call get on it, and then you can get your response, parse it as JSON, and make assertions about that. We also did some testing in the browser. So this is similar to what you get with Robot Framework and Plone. We used PyTest BDD and behaving. PyTest BDD is the thing that lets you write a test in this style where it's sort of a specification of when I do this, this should happen. And behaving is providing the particular commands to interact with the browser using Selenium. I think behaving was created by Jorgis, who's an old Plone guy, works with Gear on Crypho these days. The final sort of testing we did was some load testing to make sure we could handle all that traffic when registration opens up. We did that using a tool called locus.io, which is just an open source Python package. It lets you write some Python code that says, these go load these HTTP endpoints basically, and then when you run it, it will fire up a bunch of workloads that will do that in parallel, and then it'll give you some reports of how it did, how many errors there were, that sort of thing. So we actually found a problem on the Salesforce side with this where we weren't locking something properly, and it was possible to fill something up past the level it was supposed to be, the capacity before you start adding people to the wait list. We found that with this, and we're able to fix that in Salesforce before we launched. All right, shifting gears, let's talk about the front end. Talk about React. React is A system for structuring your front-end code into components. It encourages using a syntax called JSX, which lets you mix HTML-like markup in with your JavaScript code. So it looks like this. Here we've got a button component. It's got a render function that's going to render an HTML button. It uses this.props.label, so that's a property that was passed in. It's got an onClick handler that's going to call that click function down there. And then down at the bottom here, we're actually attaching this into the page and saying, let's create a button with a label click me and replace the body with it. So this is what React looks like. Now, the first reaction to this is usually something like this, depending on whether you are a developer or a designer. People don't like mixing the two. In some ways, I think this is like white space in Python. You'll get over it, you'll learn how to do it, and then it'll be nice to have the markup close to your code in some cases. There are also cases where you do have separate concerns. You want to have a template that can be overridden by somebody else. And it would be sort of nice if React had better support for that. Another downside to using JSX is that there's added complexity to compiling it into actual JavaScript. That I don't think is such a big deal. You're probably going to be doing some sort of compiling of your JavaScript anyway these days if you want to use ES6 features and so forth. So it's just one more thing to add in there. Another downside is because JSX was originally written as to compile to JavaScript, it has some subtle differences from real HTML. Class is a keyword in JavaScript, so they couldn't use it. So whenever you run a write class equals something in your markup for React, you have to say class name equals. That is a practical annoyance as well as a theoretical one, because it means you can't just take some HTML and copy it in to use it in React. You have to go through and search and replace. I'm actually working, have done a little bit of experimentation with creating a template engine that renders the Jinja 2 syntax directly into a virtual DOM React style rendering so that you can get React style performance. Hoping to do some more work on that beyond just the proof of concept. People get excited about how React can help with performance, and if you start using React, you'll start hearing all these things about the virtual DOM and immutable JS and one-way data flow and Redux, and you sort of throw up your hands and say, oh, what have I stepped into? I don't think you really need to worry about a lot of this stuff in a lot of cases. The main thing to know about React and performance is that when React renders these components, it constructs some just plain old JavaScript objects that represent the structure of what should be rendered into the page. That it then compares them to the actual document object model, what's in your browser, figures out where the differences are, and then efficiently updates it, as opposed to a classic template rendering system where your template renders to text. You then parse that text in and create update the DOM as you go. So that alone helps with performance a lot, and there's all these other things you can do to keep React from even needing to call the render function to figure out what the virtual DOM is that it's supposed to render. But you're really only going to need that for a site where it's updating frequently or rendering a large number of things. For something like a content-centric site where you render the page once and then maybe again once somebody submits a form, it's not really going to matter that much. So you can start to dabble in React without learning all about these things. Another thing that people get excited about with React is isomorphic rendering, which is saying you can use the same templates on the client side and the server side. And this is true. You can do this even in Python, which you wouldn't necessarily think, because you can have your Python render something to JSON, and then you can pipe that to another process, which is running Node and runs React and spits out HTML, and you can serve that. I have done that. Well, really, Lawrence did it, and I helped on that system. This is important for if you're doing a site that's going to have public-facing content and you want to make sure it can be indexed, because these days Google will try to render content even if your website is rendered as a single-page app using JavaScript, but it's not always perfect, and there's other search engines out there that aren't going to do that. But for a private site, like much of the WTA site, it's not really worth the effort. What we ended up doing was the main view of a work party. We didn't use React for. We just wrote that on as a server-side template. And then the things that were more interactive, like the registration form that didn't need to be indexed, we did with React. So there's all these things that people get excited about. The thing I'm excited about with React is that it's declarative. There's a clear representation of what the state is of the data in your application. And when you update that state, it will take care of automatically and efficiently updating where that state is reflected in the rendered page. That's really nice. For me, that's a revelation almost as big as when I learned how to use jQuery the first time. Speaking of jQuery, this is a counterexample of what React helps me avoid. So I found myself doing this all the time, or at least I used to. So this is like, you got this form, and whenever this checkbox is checked or unchecked, you want to show or hide something in the form. So this is how you do it in jQuery. Like, you grab onto selectors for each of those things. You write this function which is going to look at the state of the checkbox. It's going to toggle the class on that section. Then you need to wire that up so it's going to get called whenever anything changes in the form. We need to update the form, and then we also need to call it initially just to make sure that the state of the form is right when the thing loads. With React, all we would do is we would have whatever thing contains this form would have some state which is whether or not that thing is open. And the button would update that state and toggle it on or off, and that state, when it's toggled on or off, would trigger automatically re-rendering anything that depends on that state. So you have to think a lot less about when I change this, what is it going to affect. A lot more of that happens automatically and fairly quickly, even when it needs to re-render a lot of things. Now, of course, React isn't the only framework that supports this sort of data binding. Angular is going to do it. Probably a lot of things do these days. If you got something that you're using that you like, maybe I would argue there isn't such a big need to look at React. If you aren't using something like this, I think React would be a good thing to look at or to consider because of the work it's done on performance. We came up with a couple patterns for using React within Pyramid. And I think I might actually skip a couple of these slides because I'm running short on time. And I want to talk about how we integrated the Pyramid thing with the Plone thing. So if you want to know a bit more about dealing with React, with the client-side stuff, talking to the backend stuff, you can talk to me afterwards. So the things related to integrating with Plone were, we have shared navigation. So this is the nav bar at the top of the site. That's all folders and pages that are set up in Plone. But it also appears at the top of the VMS system. And the way that's done is we have a REST endpoint, well, a JSON endpoint in Plone itself that spits out a JSON representation of what the menu items are. And then on the side of the Pyramid app, we just load that JSON and then render it in a React component that happens to generate the same markup as is generated on the Plone side. I'm not sure this is, we could have probably just pulled in the entire chunk of markup that's used in Plone. This is interesting, I think, partly because it reminds me of some of the work that's being done on the Plone JavaScript client that people were presenting on yesterday, and the idea of turning Plone into a system that's decoupled, where the navigation JSON component is built in. And in fact, I think some of that exists in Plone.REST API already. If it had existed and I had known about it when we built this, it would have been useful. there's things you need to think about because these systems were designed to run on separate domains. You have to think about cross-origin resource sharing. Whenever something is being loaded over Ajax from a different domain, there's restrictions that the browser places on what you can access. I'm not going to go into detail on these. These are the various headers and things that you need to read about and be aware of. These days, I would look at plone.rest, which is the new library for registering REST endpoints for Plone. It's going to help you specify some of these things when you create an endpoint in Plone. And then I talked a little bit about, oh, this got really small, I'm sorry. I talked a little bit about the single sign-on. For login, we're sending you over to Plone. We've customized the Plone login form so in a couple ways. Number one, if you're already logged in to Plone, at that point it will just redirect you back to Pyramid immediately, so you end up back there logged in. If you're not logged into Plone yet, we let you log in, and then we determine if you came from VMS, and if so, we add that. Create this JWT token, which is basically some JSON that describes who the user is, and it's signed with a secret, so that when Pyramid gets that, it can verify the secret, know that it came from Plone, and say, oh, I should create my own session for this user so that they can be logged in to VMS. And then we also handle going the other direction. If you click log out in Pyramid, we actually take you to the Plone logout screen so that you will be logged out from Plone also. But the Plone logged out screen also includes a view from Pyramid that will destroy the Pyramid session. So we end up destroying the two different sessions. I believe we have a couple minutes for questions. Is that right? Yeah. If you have questions, you can reach me here. Don't forget to fill out the talk feedback from the 6 Feet Ups app. Thank you, everyone.